Thank you. Wow, that's weird. Let me start over. Thank you for saving me, MOSFET. I was just saying welcome back, and you told me my mic was off. Wow, how unprofessional. Oh well. You have very good news. Well, I always like good news. My good news is just that I'm here again streaming. And so very excited to be here. We'll hear what MOSFET's good news is in just a sec. Let's see, we're streaming Python and SQL, data science, and a problem called customer churn. My name is Carl Gold. I don't think I mentioned that with the microphone on. And I am a data scientist, and I'm here in Silicon Valley, California. So for me, it's still afternoon, but good evening to those of you on the East Coast or wherever it's evening. And good morning if anyone on the other side of the world actually wakes up for this. I keep hoping that someone will. You never know. So we're still waiting for the good news. MOSFET, what are this good news? I hope the good news is that you can hear me now. I can see the levels on my mic. It's actually working. All right, let me move forward. In my streams, I usually spend a while talking about what I'm doing and the background, the domain, I guess as we say in data science. The domain knowledge is important because if you don't have it, you don't know what you're doing. So what are we doing here in this stream? I'm going to talk for a little bit, giving background, and then I'll get into code and hacking in a little bit. Okay, you could manage to do the simulation as SQLite DB. Okay, that's interesting. Let me explain what churn is, and we'll hear more about the SQLite DB. So churn is subscribers, customers, or users quitting, and that's for any product or service where you want your customers to come back. So that could be, okay, so simulation in 8 minutes. Well, that is definitely better than my simulation in Postgres, which takes like 20 minutes. So let me keep going. Let's see, we do churn for paid subscription, in-app purchases, and ad-supported products. The origin of the term is from the churn rate, the percentage of customers that churned or dropped out. And we are going to be talking about churn rates in this stream in just a little bit. I've been calculating churn rates lately. But churn is not just a rate, it is also now a verb, as in the customer churned, or even I'm churning from Hulu this weekend because I'm sick of, I don't know, whatever's on it. I don't actually have Hulu, I was just making that up. And churn is also a noun. You can say make a churn report, or even you can say a customer churned or the customer is a churn. So that's kind of the background on churn. And why learn churn? I throw this in there. Well, I would say churn is the most common data science problem out there because every product nowadays wants their customers to keep coming back. The whole world has gone recurring or subscription. And in this stream and in my book, you'll learn special tricks and techniques that you won't find anywhere else for churn. Also, it's great beginner's data science. In the book and on the stream, I cover an end-to-end view of one data science problem, starting from raw data and going all the way to what you would do to reduce churn, which is, I'll go to that in just a minute. So that's why churn is interesting for people who don't know about it already. What is Fighting Churn with Data? That's the book that I wrote. It is actually out now. Got to show everyone the copies. It's been so long coming. Based on my experience as chief data scientist at a company called Zora, which I'll tell you about in just a minute. And there's a discount code shown here if you want to pick up a copy of the book. But of course, you can benefit from all the free source code and everything you need to know about churn just by following on the stream and going to GitHub to get the code. Let's see. What is Zora? That's the company where I work. It is a platform where others run their subscription business. For example, Zoom is a company that's on Zora. Zoom is also now a noun and a verb because everyone's on Zoom meetings since shelter in place this year. And so Zoom runs their business on Zora. They track their customers and their subscriptions, their billing, their accounting, all that kind of stuff. So that's what Zora is. And by working at Zora is where I've done a lot of research on churn for different kinds of companies. Now, what do you do about churn? Well, we teach data-driven churn reduction, which means using your data to improve your product by finding the best features without surveying your customers, which is biased and a pain. You can do marketing. You can reach out to those customers using your data to make sure that you get customers useful messages and not just spam. You can do customer success and support, which means helping your customers and use your data to figure out who needs help. And lastly, you can include your sales and pricing and have people right-size their plans. Now, Mosfet was talking about a simulation which he did in 8 minutes. My simulation sadly took around 20 minutes. So I'm curious to hear, you did the simulation into SQLite DB memory, and then curious to know how if you then transfer that to another database, or if you're just running the entire book out of SQLite. That would be interesting. So last week I was talking about the setup from the book, because the book comes with a bunch of code, which we're going to look at in just a few minutes. And you can get all the code at my GitHub repo, github.com, Carl24K, Fight Churn. And there's the usual instructions. You got to clone the repo. I teach everything using Postgres database, and so you'll have to install that to run the code as it is. And I tend to use PyCharm, which is an integrated development environment. We've been discussing PyCharm versus VS and scripts, notebooks. Those are all options. And so then, of course, you need to create the schema and run a data simulation, which is the simulation we were talking about. And so we talked a lot about the simulation last week. So let's do enough talk. Let's look at some of the data that we created. I like to show people the raw data at some point in the stream. Let's see. I have a bunch of schemas here because I've been doing this a bunch. I'll just look at this one. Let's do some queries, actually. These are queries that I had from my stream yesterday. I see. Okay, so Mosfet is saying he is not using Postgres, but he is using SQL Alchemy and Pandas and pipe it into any database. Okay. Oh, so you do end up piping it into a database. Interesting. So I wanted to show you some of the data here. So we have a few kinds of data. First one is events. Let's see. I'm going to show you some of the event data that we created. This is some event data. Let's see if this basic query works. So we created a bunch of events. They don't look like too much because each one has an account ID and a time, and that's because these are events that happen at a point in time. And here I've just got the event type ID. So let me go on and join with the event type table, and then we can see the names of the events. Let's see, join event type T. I'm going to give these letters. D, so I can make my join condition more concise. Let's see, event type ID. So there's an event type ID, which is what I'm going to join on here. And let's see if this just works. All right, so now you can see that these events actually have a name. I seem to be only selecting event type 0 here. Let's do order by event time depth. We'll see some of the events here. Let's see. The best thing about it, you do not need to run SQL. You can use the session query command on my ORM classes. Wow, now this is getting, Mosfet, you're into some stuff that I don't really know. I know a bunch of data science, and I do know a bunch of SQL. I don't know that much about SQL Alchemy or the session query command in ORM classes. But I mean, maybe, I am open to people contributing to the Fighting Churn With Data repo. So if there's some way to include this as an option in the repo, I would definitely be interested in figuring out how to do it. I want to have SQL, I let SQL Alchemy make it for me, do it for me. Yeah, I have to learn about SQL Alchemy because honestly, even though I work with Python every day, I'm always learning more about the crazy range of options that you have available. So let me keep talking about this event data. This was the event data we created or a sample of it, and you can see it's for a social network, and this is simulated data. So there's posts, likes, messages, new friends, replies. These are all the events. These are just an illustration of the events. And there are many events in this table, millions. If you want to know how many, let's just try this. And this is why the simulation took like 20 minutes on my computer, although 8 minutes apparently if you do it in Social Alchemy. Let's just see, how many events did we simulate? Hey, it takes it a moment to tell us. Come on, you can count. Shouldn't it be really quick just to count the number of records in one table? Did I hit the execute button? Oh, there it goes. That count star, something's not happening here. Oh, there we go. It really was taking a while. Okay, so it's that 16 million events came out of this simulation, and that's for a whole bunch of customers. Now let's look at the other event. The other important data that we create in the simulation is subscriptions. And there's a lot fewer subscriptions. So we made 16 million events and 54,000 subscriptions. These were each 1 month subscriptions. Let's just look at some so you can see what the subscriptions look like, because this is very important. I'm going to start hacking the subscriptions in just a minute. We'll say limit 1,000, order by, I think that they have a start date and an end date. Do you have to do the order by before the limit? Yeah, see, you do have to do the order by before the limit. All right, so here are some subscriptions. Now, these are kind of simple subscriptions. They only have one product here, and that's kind of a weakness of this. They have account IDs and start and end date. So this is, for example, a subscription representing for this account 13 going from June 1st to July 1st, and it's $9.99 a month. We don't have any quantity or units, but that's fine. We didn't really need that. Now the problem is, or not the problem, but the fact is, there's not a lot of different MRR values. Let's actually check. I think there's only one. Whoops. Distinct. What did I do wrong here? Order. Oh, can't order by something that's not in my query. Duh. All right. So there's only one MRR in all these subscriptions because it was a really simple simulation. Okay, B for Silva, welcome. I had a pretty good week. Oh, good. Glad you thought the last one was detailed and understandable. I think you mean the one about churn rates. So churn rates was what we were trying to do. Let's talk about my last stream because that's what I'm motivating to on this. Okay, this is what I did yesterday. So yesterday I did churn calculation, which is in chapter 2 of the book. And we did different versions of churn: net retention, standard customer churn, and revenue churn. But if you watched the stream yesterday, you'll have noticed that they were all the same. Net retention, customer churn, and revenue churn were all the same. And why? Because, going back to the database here, every customer pays the same thing, and it's only $9.99, because this was a really simple simulation that I did. So I didn't feel good about this, because I didn't feel good about this in the book either, but I felt even bad about it. What I'm going to do today is I'm going to try to upgrade the simulation to include upgrades and downgrades, and then we can try redoing. I can try redoing revenue churn. Well, actually, everyone can try it because I'm going to make a branch in the repo, and anyone who wants to could run this simulation by pulling out that branch. Well, after I get it working. And then we can redo the churn calculation demos and actually show differences between net retention and revenue churn. Now, the challenge of this is I don't really remember all the details about how my own simulation works. I wrote it, something like a year ago or more, and then I was working on it for a while, but I kind of just left it. So let's go look at the simulation. Actually, maybe I have one more slide explaining, a little explanation of the simulation, and then we'll go look at it, and I'll try to hack it to include upgrade and downgrade subscriptions. Not hack it, but it'll be hacking because I'll just be doing it live. So in the simulation, for each customer, that you generate, each customer has a set of rates for the behaviors in the simulation. And those behaviors were these things we were looking at. If I go back to one of these past sequels where we looked at the events, I guess this is the one that works. So these are the behaviors, things like posting, liking, messaging, having new friends. So those are the behaviors we're making, and each customer you generate has their own propensity or rate of doing those. Then each month, the customer gets a subscription, then you randomly generate the events for the month, and you simulate churn from a satisfaction model, which I explained in last week's stream, all about the simulation. I really beat the simulation to death last week. So if you want to know how that works, you can check out that stream. Now today what I want to do is add some random upgrades and downgrades instead of just plain simulations. And hopefully by doing that, we can actually get a more interesting result. So this is going to be a demonstration of how to do your own simulations based off the simulation framework. And hopefully I'll get a useful result that we can use to do better churn calculations, assuming I finish it in this stream. I don't even know how this is going to go. So let's go to the code. I'm going to go to churnsim.py, which is in the data generation folder of the repo. So this is in the file churnsim, and this is the function simulate customer, which is kind of the main entry point I'm going to be working at. I'll just show you this first. This is where we make a customer. All these 4 lines here are kind of like the random generation of the customer. This is the main generation of the customer, and this is the loop where we make a new subscription. And you see the subscription is a simple start and end date here. And this is actually the main thing I want to change. We want to get some more interesting subscriptions. And then we generate the events for the customer in the month, simulate churn, and if they don't churn, you can iterate to a next, a new month, right? But so what I want, my goal is to make these subscriptions more interesting, because now where does the $9.99 MRR come from? That's actually I have it hacked somewhere else. I was looking at how this works yesterday. Let's see, I need to go to, let's see, somewhere in here. This is the loop that creates all the customers. Yeah, I've hard-coded it. I'm just trying to remember where. Oh, it's here, I think, in copy customer to database. If I scroll over, yeah, here's the $9.99 hard-coded for every customer. Now that's what I don't want. So I want to basically stop doing this, and I'm going to start, I'm basically going to make a third field in my subscriptions, and so now my MRR will be the third field. All right. But you know what? I shouldn't start hacking yet. I'm actually doing bad software engineering practices. I need to make a branch. I said I was going to make this available, assuming it works. So let's see. First I'm going to go into my friendly source tree. I do Git with source tree. I'm kind of a GUI loving person. So this would be the great time for us to have a nice debate over, using like source tree versus command line Git versus using GitHub website. I just like using graphical user interface or GUI tools. So I'm just going to make a branch. I always name my branches by date. I don't know actually, that's another good thing we can debate. What's the best practice for naming branches? I don't know. I use the date. This is in my own work. At my day job, we link it to Jira and our stories for agile programming. Here I'm just going to say, I'm going to make a branch with the name of the date. I'm going to call this multi-MRR branch, so that whatever hacking I do will be, whoops, I gave it the wrong date. Nice one. Let's rename it to the right date, 1206. All right, now whatever hacking I do is going to be in this branch. And like I said, so now I'm going to start hacking. I'm just going to do this, I don't know. I shouldn't do this yet because I haven't figured out how I'm going to get the MRR in there, but we'll be able to see. We'll be able to figure it out. what I need to do actually is define a new model because I don't want to screw up my old model. So I'm going to go quickly to the folder where the model configurations live. And I kind of explained this in my stream from last week about the simulation. So let's see. This is my checkout for this version. And in the data generation, there's a conf for configuration folder. Hope you guys can see this. Maybe if I make those bigger. Oh, it just makes the folders bigger, but you still can't read the letters. That's kind of lame. So I have these configurations, and everything in the book was the SocialNet 7 configuration. And I'm just going to duplicate these because I want to do a new model. So I'm just going to like paste those 4 files in and then go to all the copies. And let's see. Let's rename these if I can. From SocialNet 7, I'm going to call these BizNet 1 because I'm going to pretend this is a business product with multiple plans. Wait, no, I need to keep this one the same and call this BizNet 1. I want to rename those, and I want to also get rid of the copy that we got in those names. Rename 6 items, space copy, and get rid of the copy. All right, so now I've got my new set of files. Now these are the configurations that tell the simulation what the customer behaviors are. And we looked at these a little bit in last week's stream on the simulations. This is saying that the average number of posts per month is 20, the average number of new friends per month is 5. These are all just the simulation values. And this is a correlation matrix for the behavioral rates that the customers have. And I went into all this in great detail last week, so I'm not going to talk about it today. I just wanted to show you what I'm doing. Now, I've actually got to what I've got to do now is I need a new configuration because everything in the simulation runs on configurations. So what I need is to make a new configuration that's going to have my plans. So let's see. How should we do this? I'll just, let's see, this will probably be good because it's a 3. I'm just going to duplicate this file, and I'll open it up in a sec. I'm going to call it the plans file, and I'm going to call it plan. I'm going to just make this big. I'm just making a configuration file so that in the future, if anyone wants to do this, with a different way. These are the 3 channels. You might notice in the chapter 10 of the book, it talks how customers come from different channels. I'm not using that. I'm just reusing this file here. So I'm going to have 3 plans with 3 different MRRs. I'm going to have basic, standard, and premier. And let's say, whoops, the basic plan can be $59.99. The standard plan is $200, and the premier plan will be $500. I'm just making this up. We'll see what this does. So this is the cost. So remember, I'm saying this is a business product now, so higher prices can be okay. So I've made a file which is going to save what my plans are going to be, and then I'm going to have to load up that file. But first, I also need to create the schema. This will be a good demo of what you have to do. Sorry if I'm jumping around, but I didn't plan this out completely. Next, I'm going to go and create the schema. Let's see, we'll give a probability to the MRR. That's a good idea. Maybe I should have a probability to start on each plan. I'm going to have a probability to upgrade and downgrade, which will be the interesting part. And I haven't totally decided how to do it. So yeah, so there should be a probability, because you're going to have to start with 1. And let's just say this one is like 5, 0. 3, 0.2. So we'll just like start out with those. And then we're going to have an upgrade downgrade probability, which I haven't really worked out yet. But let's go back. Basic should be huge, no? I guess, yeah, I mean, most people should start on basic. But let me create the schema that I need, because I'm making a new model, and I called it BizNet1. This one is hard-coded SocialNet 7. God, I have so many configurations in here. ChurnDB, looks like I can add the schema as a parameter, and that should be it. So this is just a demo of how you create the schema for all the tables needed. There's a script for it. It's called ChurnDB. If I run this, it gives me an error. Let's see. Oh, it's schema name. I didn't get the parameter right. Oh, and also, this doesn't use the arguments. See, I don't remember my own code. This one, failing to remember my own code. This one just takes one argument without a flag. That's what I see now. I'm just using sysrv. All right, live debugging, hacking. All right, so now I've created my schema for the BizNet1 simulation, which I will hopefully be doing soon. When I go back to my database, I'm just going to make sure it's here. I might need to like refresh. Let's go back and go back in. I want to see it. Let's see. I want to see some evidence that my schema creation actually worked here. I think I should try to get open pgadmin. So I will do a new pgadmin window, kicking it off here. Whoops. And unfortunately, it's opened up in the wrong window, but hopefully I can drag it over. If I do this, and then there we go. Okay, here's my pgadmin window. Let's connect. Schemas. Okay, here is my new schema. This is what I wanted to see. You know, I ran the script to create the schema. Let's see. A free plan. That might be interesting. We could make the free plan really free. But look, so this isn't, I think not Enver, oh God, MOSFET, more suggestions on the Enver plugin. Yeah, it could be, there should be it. And I really just use, the thing is I just use the schema for the churn model. If you look everywhere else in the code, I'm going to be like BizNet1, BizNet1, and that's the schema for everything. Now, I don't want to deal with a free plan right now because I just want everyone to be paying something. But that is a good suggestion. Maybe eventually we can make an even better simulation. But just for right now, I want to get some different levels of MRR into the simulation. So I've created my schema. Now I've got to go back to my code and remind myself where all of those configurations get loaded. Because, let's see, I'm just looking. Where do I load all those configurations? Probably up here. So here's where I load the utility model. And what else do I load here? Okay. Population percents. I think this is basically what I need. So I'm going to say, I'm just going to like hard code this right now and say self.plans equals read CSV. Whoops. And let's see, this one is, see, I have all these configurations getting loaded here. So I'm just going to load one more. And it is going to be, let's see, wow, that didn't work. Failed copy paste. Let's try to copy paste everything in here. All right, and this is going to be, so it's going to be model name underscore plans. I think that's what I called the file. All right, and that's where I will get the plans. And let's see, then I'm going to need the plans when I generate the customers. Should put a breakpoint here just to make sure this works. Always a good idea. Let's see. So now, I'm gonna like close this up a little bit. Let's see. What's the purpose of the plan? So the plans is basically the levels. So the plans is gonna have different amounts that people pay. Now, eventually, this simulation should take into account how much people pay, and if they pay too much, it should make them more likely to churn. But I'm not doing that today. No promise that we're going to use the amount of money they pay in the churn simulation. I'm basically just going to try to have them start out on a plan and then randomly change to other plans, just so that we can get some action happening when we do net retention and MRR churn. So here's the simulate customer loop where we were working. So we do generate customer where we pass in this new customer. And I'm like setting the customer country here. This should really be in the customer, honestly. How does it relate to the MRR? Well, each plan has a different MRR. So each plan has one MRR, so the plan is basically synonymous with the MRR. The MRR is the monthly recurring revenue, which is how much they pay. So just back here, I'm basically just saying, there's 3 amounts that people can pay, and this is my name for them. So that's all it really is. So let's see. We want to do something like, we want to set an additional variable on the customer. And I feel like I don't like the fact that I'm setting the customer country here either, but I don't want to change that now. So I want to go to customer and have like a new method in customer. So right now, what happens with a customer? They set their rates and some basic stuff, and they get an empty list of subscriptions. So let's just get a new one, like a pick plan function, which will take the plans. And let's see, I need to do like a cumulative random or something. I should have an example of that here. Return uniform 0, 1. So I'm going to import uniform from random. Let's see, did I already have it here? Oh, well, I already had that. So we'll just import uniform. Let's see, and then let's see, pick plan equals uniform 0, 1. There's got to be I know there's an easy way to randomly pick. So I have my plans. I want to randomly pick the plan which is below, the one indicated by that. Let's see. I think this is actually what I want to use. Oh no, this is actually what I want to use. How I pick the customer model. Sorry. I don't want to use uniform random. Let's just do this. Let's see. Let's try plans. I'm going to try to pick the MRR. And here we're going to use, I think I'd better start debugging this. Plans, prob. Okay. So, well, that'll be the easy way. Boy, I really could have done this in the other, let's see, I'm going to preset the MRR here, self.mrr equals none, and it will be, set up later. I think I need to actually start running this to make sure that some of this actually works. So here we're going to do new customer.pick plan self.plans. It's basically what I should have done with the country picker. All right, I'm going to try to run the simulation up to this point. and see if at least I've loaded my configuration and if I can randomly assign these plans to the customers. That's going to be the first thing. It's probably going to crash spectacularly. So, actually, wait. Now I have to check the parameter. I have to tell this to use my new model. This, which is also, okay, just a simple command line argument. Let's see. So, all right, let's see if I actually make it to my first debug point without throwing an error. Also, I'm going to lower this init here to only like 100 customers just to make this a lot faster, because we don't want this to take 20 minutes, right? Let's just try hitting the debugger and see if I actually even load my model correctly and, really if anything works at all. Key error. All right, that figures. All right, I must have a typo, I believe. All right, something's wrong. I actually made it up to here. Maybe I misspelled my model. Take two. Let's see. Now, my model name is BizNet1. Model path, 1 web. Let's see. And these should work. So can I load that CSV? So here's the, I'm just checking if I properly loaded the model. Yeah, that looks fine, This is that model describing the customer model. So this looks fine. Why am I crashing? I didn't even change anything here. Where was the crash from before? This all looks fine so far. Where was the crash again? I don't want to keep breaking here. I want to get to my next break point. Hopefully somewhere more interesting. Well, I'm just trying to get down to there. It looks like... Oh, I hit the fail again. What is the error again? Oh boy, not starting out too good. Model set index behavior in place is true. Select error set index key error format missing. What the heck? I don't know what's going on here. This usually works. I should try running my old model first before I start hacking this one, or I'm just going to end up in like some going way off into the weeds. So the crash was happening somewhere around here. Fat-tailed behavior model. Does this crash it? Okay, I think this was the problem. Behave mod is what? And behavior models is what? Dictionary? Alright, so that's fine. That's fine. No, that's what's crashing. No, that's fine. Making me crazy. Where's the crash happening? Oh, there it was. Key error. Alright, I'm sorry people, but I am like failing here. Model set index. This is the problem here. So it's saying like that behavior is not in the model. Let's look at those model files again. Behavior, yeah, looks fine to me. I am not at all doing well here. I'm not even getting up to the thing that I wanted to do. You think it could be the plan? I don't know. I haven't even gotten to the plan yet. Let's see. Model set index. This should be fine. That worked. I think one of these models, oh, see, oh, you're right. It is my plan. Why did it load the plan file? What the heck? It loaded the plan file when I thought it was loading a behavior file. What is it doing? Maybe it saw the file and thought it was like, oh, wow, it is calling it with the plans. Did it just like list the files or something? Why did it think behavior versions? Oh, anything with this format. Oh God, I am so dumb. See, I don't remember how my own thing works. Let's see. This is just saying model name star is considered one of these plans. So I need to actually, let's see, well, these other things don't. Behavior and see, yeah, but I don't want to, because I don't want to replace plan with behavior, because here I want it to not load all the files. Why doesn't it load the others? Version, oh, see here, this is it. I basically have to say if, this is how I skip the other files. See, this is the little hack. This is what I get for being a hacker. My own hacks come back to me. Okay, this should be the fix. I had to put in this lot. I had to enter it in this list here of the files that look like model files but really aren't. Okay, I am a hacker, but I think we can now make it past this bug. All right, let's try it again. See if we get to something more interesting. I don't even want to stop here anymore. I just want to get to my next breakpoint. Okay, here's the breakpoint that was supposed to work, where I load the plans file. All right, so now I have loaded those plans, which took a lot longer than I had hoped, but here is the plan data that I had tried to get. Basic, standard, premier, 59, 200, 500, and the probabilities. Okay, let's try to get to the next place where we're going to use this to pick an actual plan. Okay. Whoops, maybe I already have a breakpoint there because I set a few earlier. Whoops, that's too many breakpoints. Maybe I'll just scroll down. Down in the simulation. So here was my new customer pick plans. This was the next thing I was hoping to reach. All right, here I am creating the new customer. These were my breakpoints from when we were doing the customer simulation last week. Here's my new customer pick plan method. All right, finally testing the thing I wanted to test. And let's just try this out. I'm just going to try this random choice function. What this random choice function does is you give it a list and you give it probabilities, and it should pick with each probability. So here we go. Yep, I'm evaluating this multiple times, and it does pick the plans with different probabilities. All right, so now my first customer got an MRR, and so I made sure this stuff works. I got through my first hurdle here, which is to get the customers loaded and picking their first MRR. That was the easy part. But now I want to write that into their subscriptions as well. So customer, so he's got an MRR. Now I want to go to like there's an upload customer to database function. Remember? Oh yeah, when I make this when I make the subscription, that's where I enter it. So here, when I do simulate customer, oh yeah, it's in this hidden part here. Got to open up that. So now, when I make the new customer, what do I do? I'm going to do subscriptions.append. This is where I'm going to do it. I think here, if I just append new customer.mrr, really I should make like an add subscription method. Okay, can you think where you derive this from? Customer rates equals, oh God, I'm gonna have to remember. That was meant to give to make sure that there's no rate less than a certain minimum. So I put like So that way the minimum rate becomes 0.333, which is like, 1/3, I guess that's 1/3 of an event per day or per month. And it just seemed like a rate below that was like too low. Again, the truth is I hacked a lot of these things in this simulation a long time ago. And look, I'm going to be honest here. I haven't done everything here perfectly. Are you noticing that? Do I seem defensive? I don't mean to be defensive, but the truth is I had a lot going on as I was writing this book. I did not quit my job or, quit anything to write this book. So I did the best that I could. Just not gonna lie, I did the best that I could, but there are some rough edges. And there are a lot of things that I kind of hacked in it, to get it to work. And so this is basically gonna be one of them where I'm just gonna, I should actually see if it works now. This is just gonna be appending the MRR with the subscriptions. And in that other place where I was loading them, I was putting that third element here in copy customer to database. So this should be where we're just looking at that. It's probably hidden because I collapsed everything, right? Yeah, it's in one of these. So this is where the subscriptions are written to the file. And here I added the third element. So I'm actually just going to try to run this. I'm going to give this a run because I think at this point I'm going to write my random MRRs to the subscription. So I'm going to live dangerously and I'm just going to try to run this. And remember also, I set it to only simulate 100 customers. So this should be fairly fast, whatever it does. If it works or doesn't work, this will be fast. Let's see what happens. Nope, it crashes. All right, tuple is out of range. That's where it was supposed to be in range. Maybe not all of my subscriptions are getting the third MRR component. So the question is, where else do we add subscriptions in the customer? Because here's where I added the subscriptions. Let's see, maybe there's another place where we make the first subscription. Let's find usages of this subscription variable. I probably missed one. Subset subscriptions is an empty list. Here, this is where I'm reading it out. Create customer for month, total subscriptions plus equals customer dot subscriptions, simulate customer. I'm not really seeing where else that will happen, but I'm going to hit the debugger again and I'll try to step through it. Let's see. So new customer, I know that pick plan works. This is where I add my subscription to my new customer. Let's take a look at that. I'm going to go down here to the debugger, look at the subscriptions list. And the first element looks like I want it to. Let's see. I don't want this breakpoint. I want to break at the part where we're adding the customer to the database. This I don't want, that's a breakpoint from last week. All right, appending a new subscription. All right, now this is where I'm going to try to write it to the database. And let's look at all the subscriptions for this customer. I just want to check that they all have what they should. They all have the MRR. Oh, I see. I'm missing like I don't know. I don't see. That actually looks fine. Sorry, psych. Let's see. This is where I write them. Oh, is that what's crashing? I think I'm I'm crashing. So I'm crashing here. And why? Oh, because I said 3, not 2. Duh. Python indexing starts at 0, people. How many times have you made that mistake? I make that mistake, I think, because I work in R a lot, which is 1 indexed. All right, now it's in churnsim.b line 108. All right, let me try running this, and then we'll go to churnsim line 108 to look at that line. Let me just see if I got this working. All right, I think this is working. It's just making my 100 initial customers. Oh, am I in debug mode still? No, it's not in debug mode. Okay, there's my new customer simulation. All right, my new customer simulation worked. Hey, Scott Edwards, welcome back. Nice to see you there. I am hacking the customer simulation. So we wanted to look at churn SIP 108 to explain this line. Where I said, wait, is that the line you wanted to? No, you were just helping me out figure out where I was with line 108. This month, next month. Yeah, okay, so I think it's good. I'm actually going to go to, Rodrigo, live debugging. I am live debugging. This is a hacking kind of week. The thing was, I wanted to make, what happened was I wanted to make a better simulation, but I didn't have any time this weekend. So, and it basically was like stressing me out that I was like, oh, I have to make a better simulation for my live stream. But that's the great thing, I think, about live stream coding is I don't have to make a better simulation to show you on the live stream. I can just make it on the live stream. And, that way I don't have to worry about when I'm going to make the simulation because I already had, I blocked out the time for my stream. Anyway, let's look at our new results in the subscription table. Maybe if I just go through here. Now I'm going to go to BizNet 1 subscriptions. Oh, I need to... let's just look at distinct MRR from BizNet 1 subscriptions. So now I've got 200, 500, and 59.99. I should really just make that 60 or something, or it's like going to be driving me crazy. So let's actually do, let's count and see if our probability worked. This will see, because remember, we should have 50% basic from this configuration file, not this configuration file. This configuration file, we should have half 59.99, 30% standard, 200, and 20% 500. I'm just going to change this to 60 right now so it's not like driving me crazy forever. This doesn't have to be that realistic. Let's see. So let's just do and I need a group by here, group by MRR. And yeah, that looks about right. Roughly 50% the $60, and yeah, definitely probability works. The NP random pick. Now, this is a good first step. So I'm generating customers with subscriptions. Now I have to upgrade or downgrade them. That's actually the part I haven't really figured out yet. So let me have a sip of tea while we think. It should be part of the churn simulation where each month they have a chance of upgrading or downgrading. And in this utility model, we have like this simulate churn, which I thought would be good to tie into it. Basically, what I want to do is if they have a high probability of churning, but they don't churn, then they should downgrade. And if they have a low probability of churning, then they should upgrade, basically. That's what I want to happen here. So I'm going to like maybe do something in the utility model, which is where I have this other stuff for simulating the customers. Whoops. So this is the utility model where it simulates how happy they are and if they stay or go with this little bit here. Using the churn probability. So let's see. What I want to do is simulate, let's just say upgrade, downgrade. And what we need is, well, it should basically work like the churn simulator. Event counts, customer, plans. Now let's see. There's the churn probability function, which is the utility the self.kappa is offset. So this is going to be the probability of churn. And basically, like I was saying, the probability of upgrade should be similar and downgrade should be similar, but just a little bit different. Let's say, I'm just gonna like try to come up with something simple. Let's say if we define a downgrade probability from event counts and the customer. I'm going to do this same thing here. I'm just going to like modify it a little bit. This will be the downgrade probability. Oh, gotta drop. See you later, Scott. Thanks for dropping by. We'll be back next time. Yep, live debugging. Okay, so now what I really want to do is just have the downgrade probability be somewhat a higher probability than the churn probability. And to do that, okay, utility, more utility. Let's just say that this could be, I'll reduce the utility, I'll just like, I don't know, try like a 0.5 multiplier in here. Again, I don't know how this is going to work, but I'm just making it up. So simulate, upgrade, downgrade. So here we'll say downgrade probability equals self dot downgrade probability event counts customer. And then I'll have upgrade probability. Oh, I need an upgrade probability. Now the upgrade probability is basically going to be the opposite of the downgrade probability. How about let's just make it simple. Let's call this like the upgrade probability. Let's see. Again, I'm just trying to make this simple to get like a little bit of behavior in this. All right, this is going to be self.upgrade probability. Event counts customer. Now I see this could be more efficient, obviously, if I calculated the utility first and then passed it around. Should shrink the number in the denominator and make the probability higher. Do you think for the upgrade? So maybe double this one. Let's see, what, and this one should be just 1 over this. Let's just actually go into this and see what happens actually. I just want to like try, I want to see if I can get this far and make sure that the code actually works. So let's go back to the usage of simulate churn, which is here. If not churned, here, now I'm going to say self.utility model simulate upgrade downgrade on the same thing. Month count. This thing is kind of getting in my way of seeing. Now I haven't actually used the plans yet, but I just want to make it this far. This has to be self.plans also. And then I'm going to have to go into the business of actually, let's just try to get this far. Now there's actually a new thing that's going to happen here. I'm going to rerun the simulation, and I don't think anyone on the stream has ever seen me rerun the simulation. So it should ask me if it wants, because I already put data into this schema, it should actually be asking me if, you know, I should truncate the old schema. Sorry, just adjusting my hat there. So let's run this. There's like a truncate function in here somewhere. Truncate old sim. I'm going to put a breakpoint in here just so everyone who hasn't done this before sees what we're doing. So I'm rerunning the simulation, and I've already generated data for this, and it should actually notice that and ask me. Here, it actually is doing it now. It's in this truncate old sim. It's actually now going to check for old events. And it found, I believe, some old events. If we look at the debugger. Old event. Okay, so it found some old events, and it found some old subscriptions. So it's actually checking right now. So now it should actually ask me. I'm just going to let this go now. And it's going to say, truncating events, blah, blah, blah. Are you sure? So this is actually the way you can repeatedly run the same simulation. Now, if you're just a reader of the book who just runs the simulation once, you don't care because you only run it once. Now, for the developer who's developing new simulations, believe me, you're going to run this simulation a lot of times. I ran this simulation so many times. You know why it's Social Net 7 in the book is because there was like 1 through 6. There were also a bunch before that. So I'm going to go ahead and do this. I'm going to hit OK on the truncate here. And now it's actually did the truncation, and now it's going back into the customer simulation. Well, basically, I just want to get here to my simulate, upgrade, downgrade, and just kind of make sure that that works. So here's if I call my upgrade, downgrade. This customer has a utility of, whoops, didn't want that. I just want the regular debugger. So they came up with a utility of 71, and their downgrade probability is 1.2%. I guess that's not much. Might have to make that bigger. And now we have an upgrade probability. Let's see. Right here, again, the utility is 71. Well, this is the upgrade probability, but I called it downgrade. And I call it 99. No, that's not right. No, I don't reverse the probability here. It also has to be a small probability, but it has to be higher for high utility. So this is wrong. It should be 1 minus, let's put this up probability. Let's see. The thing is, this has to get bigger for, high utility. So let's just try it like this. I'm going to hit the debugger again. Let's see what happened. Did I kill it? Alright, no problem. We already made it through the truncation. We go into this simulation. So let's see. In this simulation, the customer utility 66, downgrade probability still around 1.8. Let's see what we get for the upgrade probability. This customer, again, is 99%. Okay, I'm doing something wrong here. 1 minus. Alright, totally hacking here. Let's try this again. It should be increasing probability. I'm going to have to stop and start thinking. Right now I'm just hacking and trying not to think. Let's see. What is his probability of upgrading? Okay, that actually looks more reasonable now. So for higher utility, let's make sure this has the right convention. For higher utility, this is negative. So the exponent is going to get smaller, and this will go to 1. For very low utility, then this will get larger. Alright, I think I need to try to do something with the upgrade and downgrade probability now. So, simulate upgrade, downgrade. Now, I guess I can just try Beef Silver. Gotta leave, catch up later. Alright, have a great week. Hopefully I'll get this thing working before my time is up for the day. I've got about another half an hour to get this to work. Thank you for your patience, everyone who's watching me hack. So, let's see. I've got the plans. So I need to find the current plan is the first thing. Let's see. Current plan. I have to remember, how do you find the row? Plans is a data frame. Oh no. The current plan is the customer's current MRR. Okay, yes, I want to find the matching row of this data frame. This is where I get terrible, because now I'm going to do pandas hacking. Current plan equals plans. We have like .loc. Plans MRR equals customer.mrr. Now hopefully this is going to select out the row of the plans that the customer is currently on. That's the next thing I need to figure out. Going into the debugger. Let's just get to that line. Does this work? Alright, it's selecting out a one row. Yeah, okay, I guess that's right. And what I want is actually the first element. I'm selecting this right, but I want the index. Let's see. If I step over this, then what has that given me? I do current plan dot. Alright, I think this is what I want. This is the index of my current plan. Alright, so this will give me the current plan index, which I just did by using, I'm doing this equals on the MRR column to match the existing customer's MRR. So now the thing is, you can only upgrade if you're below the highest. So let's say if current plan less than plans.shape. So I wanted to know if this is the highest plan, you can't continue to upgrade. So then if your plan is below the highest, you can have a chance of upgrading. Current plan. If you have to be greater than the lowest to have a chance to downgrade, right? So we can't downgrade or low, Let's see. So this is my current plan. Current plans, then I have an upgrade probability. Then I can do if uniform 0, 1 less than upgrade probability, new plan equals current plan plus 1, and I'm going to reset the customer MRR. Customer.mrr equals plans. Oh god, now I have to select the right one. MRR. It's like .loc. This is where I suck at pandas, like remembering how to get the right element. Is this it? This is going to be such a fail because I'm terrible at indexing and selection in pandas. And that's why I like R. For anyone who ever was wondering, like R versus Python, this is where I hate Python pandas and I love R because indexing is so much easier. But basically, I think this is what I want to do. Once I correct the syntax on my pandas, so this is going to be where he can downgrade. Now I check if there's a downgrade. New plan equals current plan minus 1. So let's actually see if this works. And this would actually be an upgrade downgrade. You have to call Loke. Okay, I do have to call Loke. Thank you. Someone's helping me. Thank you, MOSFET. I call Loke on the column, right? New plan. Let's see, is that right? New plan. All right, let's see. Rodrigo 96, Pandas is supposed to be based on R, data frames, but it is somehow confusing. Yeah, the reason I would say Pandas is more confusing than R is because, okay, it must be low. Okay, that's what you meant. Gotcha. Thank you. I mean, the reason R data frames are easier to understand, I think, is just because they're like a first-class object. They're a first-class feature of the language, right? I mean, data frames in R are a primary type in the language. Now, data frames in Pandas are an object, and it's open source. So you have all these different kind of like, these different conventions for accessing the Pandas data frame, whereas R, it was like part of the language. Let's see if this works. Oh, I'm truncating again. That's fine. All right. So now here is where I get my current plan for this customer, which is for this customer, they're on the lowest plan. So they can upgrade. Their upgrade probability, well, in this case, was, whoa, way too small. That's not good. They have a high utility. They should have a higher upgrade probability. I think this is messed up again, but let's just see if my choosing works. So that's my upgrade probability, but they're not going to upgrade. Let's get to someone else who actually is going to upgrade. Current plan, again, 0. Upgrade probability, also a really small number. Okay, this is not right. Okay. They're also not going to upgrade. Really, let's see where, I want to just run the debugger until I get to someone who is going to upgrade or downgrade. Let's see if this even works. Uh-oh, no one's upgrading or downgrading. That's bad. My probabilities are too low. I think that's kind of the problem. MRR should be bracket MRR. Let's see, it must be loc something, comma, MRR to bracket MRR, like this. Ooh. I think that's what MOSFET is telling me to do. Or we'll see. I think I have to fix my probability model though. Oh wait, am I actually in the debugger at one of these lines? All right, someone's actually upgrading. Whoops, well I was trying to edit the code while it was running, so that's not gonna work. Here, I can test it out now. So new plan is current plan plus 1. Now does this, I'm just gonna try this in the debugger. Does this work? Nope, key error, MRR. Okay, so maybe this is what you're trying to tell me. Do I have to put this in brackets? What's the right way to do this? Cannot do label indexing on class, blah, blah, blah. Okay, so this is where Pandas always throws me. So now this makes sense. Is this how I do it? Key error. Wait a second. I think it needs to be plans MRR, maybe, because that gets me into the column. Is this it? Ah, there we go. Put new plan in the bracket. I hope this is what you were trying to tell me to do. I think this is the right thing. All right, I'm gonna hit stop here because I just figured out how it should work. MRR. All right. Now I think this should be working. Let's try debugging it again. Truncating again, because there is some data in there. What? Huh? What the hell? Did that even work? Don't know what happened there. All right, now I'm simulating. All right, here is a downgrading customer, their new plan, or no, upgrading customer, and upgrading to new plan 2. Did that work? Yeah, it seems like it worked. So what customer was that? We can check them in the database. That was customer ID. They all have an ID, 48. So once the simulation ends, we're going to go look at customer 48 in the database. And then I'm going to remove the rest of the breakpoints, I think. We are close. Is this a downgrade or an upgrade? Okay, another upgrade. We'll take out these breakpoints and just let the simulation finish now. Oh no, it's getting late and I haven't actually finished the simulation. Alright, so some customers should have upgraded and downgraded, not much. Let's look from, this is where account, there's an account ID equals 48, and that was the customer that we just saw had an upgrade. No group by. All right, so here they go. They upgraded. They upgraded to 500. All right, we now have some upgrades and downgrades. Hi, C-Films. Doing great. How am I doing? I'm good. I have been hacking away this whole stream. You've missed me being an absolute hacker, extending the simulation to have both upgrades and downgrades. Now, I'm not really sure about my probabilities. That's the last thing I feel like I need to fix here. Was that I feel like these probability distributions might not have enough upgrades and downgrades, but let's see. Maybe I can just print out some stats on it. What about plotting both distributions? Yeah, I should, actually. And then we can see, let's see, how would I plot those distributions? I could hack it, since we're hacking. Jupyter, I don't have Jupyter actually set up though. Yeah, it would be better to do this in Jupyter. Let's see. I could do like a little hack in the code just to see. I want to have like a function here. Let's see. I want to basically make this into its own little function. But you have the R plugin, or R, that's true. We could try to do this in R. I'm just trying to I kind of just want to get this done and get something working. Let's just try running this and see, look for some differences in the net retention and the churn. I think it's been too much hacking on this. I think I should just make some more customers. I'm going to go back to the simulation. I'll do a slightly longer simulation, say 500 customers, just by changing this here. We'll do a quick simulation and then we're going to talk churn. Hey, thanks for following me, Dana Boss. Welcome to the data science hacking Python stream. Let's just let this run. Whoop. That didn't really work. I think there's a bug in the truncation. Let's just try this again. All right, so there's my simulation. We're simulating some new data. We're gonna go, I missed a 1. Oh, that was why. It quit because I didn't type it in right. I'm gonna talk about churn again. So we spent a lot of time hacking some data. I think we need to stop hacking and look at churn and see if we've done anything to the net retention calculation. So churn, I'm gonna go quickly through the concept of churn while the simulation is running. I did this in the last stream in more detail, but this is the illustration of churn, where you have a certain number of customers or money. That's why I say customers, dollars. Customers or money at the start, and a certain amount of customers or money at the end. And you can imagine them as circles. So in this case, the circle is actually getting bigger. So you're gaining customers as time goes by. Now, as time passes, you're going to lose some customers, you're going to retain some customers, and you're going to acquire some new customers. And this is just a visualization of the churn customers. These are the customers that you lost as time passed. Now, if you look at the starting circle where we have churn and retention in one circle, you can see that churn plus retention have to add up to 100. Which is how we do some calculations, like you can get retention from 100 minus churn, or churn from 100 minus retention. So this is like the overview of churn calculation, simple concept. And this was my plan. This is what I did. This was the stream yesterday, but I'm redoing it now with a new simulation. That's kind of like my new plan, is to redo the old calculations, but with our new data, which actually has some upsells and downsells. So we might see something a little bit more interesting when we calculate churn and net retention. So net retention is, as the name implies, it's the retention and it's based on revenue. So here's a simple example where you have some customers in January and you have the new situation in February where you lost one customer to churn, customer 2, that's what the X means, and then one customer also had an upgrade from, this is like a $9.99 and $29.99 plan using more realistic prices. So here the amount of revenue at the start was $89.95, and then the new revenue at the end of the month, you lost $29.99 from this customer, but this customer upgraded, so we gained 20. And so our new revenue turned out to be $79.96, and you get a net retention rate of 89%. So now let's look at what happens, how we calculate it. We're actually going to now go to the SQL for calculating net retention in the Fighting Churn with Data book. First, let's see if our simulation finished. Uh-oh, did it crash? WTF. Simulation crashing. All right, this is not good. I left my simulation running too soon and it died. Upgrade, downgrade. Uh-oh. Oh, I had like a bad index or something. Let's see. Must have done something wrong. Current plan. This was supposed to prevent me from upgrading to a plan that didn't exist, right? Current plan. Oh, it should be plans.shape0. That's the number of rows. Sorry, no one caught that one, did they? All right, let's see if this actually works. So that would have been the bug. It would be kind of hard to reproduce that, but I'm pretty sure that was right. I was using shape 1 would be the number of columns. Shape 0, the plans is a little data frame, and this would be the number of rows. All right, resimulating. That's what I get for turning my back on my newly hacked simulation. Don't forget the 1. All right, my newly hacked simulation. Let's see. Oh, still crashing. What now? What's my problem here? Let's see. I'm going to re-enable this breakpoint. Look for someone who's upgrading. What am I forgetting here? All right, let's try to catch a customer upgrading. And am I at my breakpoint? Nope. Come on, someone's got to upgrade. So plans.shape I thought was going to be 3 by 3. No, shouldn't even make a difference. Maybe I need shape minus 1. Yeah, it's 3 by 3. I guess I have to be less than, oh yeah, shape minus 1 to upgrade. Sorry, still just hacking. All right, let's see if the simulation works now. Please check that the new plan is not going out of bounds. Yeah, that is what I need to do. But if I if I get my condition right here, then it shouldn't go out of bounds. That's what I was kind of hoping for. It's definitely going out of bounds. But I thought that getting the condition at the top should prevent it from going out of bounds. If I did it right. All right, I'm not turning my back on this simulation. Well, maybe I will now that it seems to be working. It won't take too much longer just to do 500 customers. But we can actually start opening up the net retention calculation code while this is running. If we just go to the listings, so net retention and churn calculations are in chapter 2. And this is the first one. Honestly, this might be the only one I do today because this hacking of the simulation took me longer than I thought. And I have to make it to the pet store before they close. So this is how we do net retention, and it is with an inner join between accounts at the start and accounts at the end. Actually, if I go back to my toy calculation here, you can see you want to check the revenue and the start at the end. It looks just like two tables, right? One table of the customers at the start and one at the end. You want to see who stayed, it's just an inner join on the customer ID. So that is what is done in the net retention SQL. All right, and my simulation did complete now. Let's see. So this is how the net retention we do start accounts. Well, I use these two dates. These are bind variables like parameters here for the start and end of the churn calculation. Because as I also mentioned, every churn calculation needs a start and an end because it's all about the passage of time, right? So this is where I set the start and end. The start accounts are those whose subscription starts before the calculation start dates or the subscription ends after the churn calculation start date. The end accounts are those that have the same condition on the end. So the subscription has to start before the calculation end date and the subscription ends after the calculation end date. Then the retained accounts are just these accounts from the inner join between the start accounts and end accounts, okay? Then we add up the start MRR, the retained MRR, and as I explained in the calculation description, net retention is just the retained MR divided by start MRR. So let's actually see now, since I finished my new customer simulation, I'm going to run this listing by making a new configuration. Whoops. If I can get there. Come on. All right. I have a lot of listings saved. Let's just go to this one. It just says generic run churn listing. Got to be careful up there. This is set to chapter 5 listing 2. I'm just going to change this to chapter 2 listing 1. And I'm going to run it. And it's going to print out the SQL that it's calculating. Oh, wait. Wrong schema, actually. This was for SocialNet 7, which is the default simulation of the book. I'm going to, this does take a parameter for the schema. Let's go to schema biznet1, and that will calculate, that will be our new simulation that I just hacked together in this stream. So now, no parameters. Oh, that's right. I have to copy the parameters. This is another thing you have to do when you do new simulations. If you get into the guts of the Fighting Churn With Data code, the book comes with a wrapper program that allows you to easily run any of the listings in the book. However, there is some configuration for the listings, and it's in this JSON file. I'm actually just going to duplicate the old one. Let's see. And then I might have to go into it and change a few things. Let's just take a quick look. This is just a step that you have to take when you make a new simulation. Let's just check that configuration. This is my new configuration. Actually, maybe I don't need to change anything. So this is how I actually set those bind variable dates. See, this is the configuration for chapter 2, listing 1. It says that it's the net retention function, and these are the start and end dates that are going to go into my bind variables. All right, so now it's actually done it. And you can see here, it prints out this SQL, and we can try out this SQL in the SQL editor, and we will see how it works. So let's see. First I'm going to do this set search path, which is a Postgres thing, so I don't have to keep typing, biznet1. I should have done this earlier. All right, that sets the search path. Now let's take a look at the SQL query. Here, I'm just going to copy all this stuff out. All right, just going to put this into the editor here so that we can, check it out a little bit. So let's see. So now looking at the different parts of this SQL, I told you the start accounts are those that have subscriptions before the start date, and the end accounts are those that have subscriptions at the end date. So I can just show you, for example, if I do select star from start accounts, we'll see all those accounts. Now here, we can actually see some different MRRs for them. This is what I was doing with the simulations. Now I actually have people paying different amounts in the simulation, which we didn't used to have. Let's see. And here's back to the whole SQL, and then we sum up the start MRR from those start accounts and the retained MRR from those retained accounts. Maybe we should look at this. Let's look at the retained accounts, and you can see that part. So if we do select star from retained accounts, it's just going to be the list of all those accounts. It actually looks just like the start accounts, so maybe not that interesting. But this does give us the net retention SQL here, and you can see at the end the formula. Retained MRR over the starting MRR is the net retention, and 1 minus that is the net MRR churn, which is not really a standard churn measurement. But let's see what we get here. So here we're getting, whoops, what did I mess up? Let's just try this SQL over again. All right, so here we get that the net MRR retention rate is 91% and the net MRR churn rate is 8.7%. And you can see what the starting and ending total MRR was. So now let's go to a different definition of churn. We're going to go through these kind of quick because I did these in more detail in the stream yesterday. Let's see, speaking of that, this is not what we wanted. This is what we're supposed to be looking at. So this was about an overview of the uses of net retention. Why use net retention? It's simple. Because if all customers pay one price or no price, then the basic standard churn rate is equal to 100% minus net retention. Now, I actually haven't explained the basic standard churn rate to you yet. The problem is with net retention, as I illustrated here, you can have upsells that cancel out churn. So in this case, the upsell reduced the churn rate but that's considered generally a problem because it's like a distortion of your churn rate. It's a distortion because you're mixing two things, like your upgrades are your excited customers and your churns are your unhappy customers, and you don't want the upgrades confusing you about who's happy or who's unhappy. Now, this is actually good for reporting to investors, and people like to use net retention to report to investors their numbers because it just sounds better to have your net retention is going to be higher than your regular retention because the upgrades offset some of your churn. Although you can have downgrades too, so it's a little bit of a mixed bag. All right, now let's talk about the standard customer churn rate. And I call it standard because it's the most common. It's just the percentage of customers that drop out. So here's an illustration of the standard churn rate. Here again, we've got like two tables of customers, one at the start and one at the end. One churns, and we add two new customers. But what this is illustrating is that the new customers you add don't affect your churn rate. The churn rate here is the one churn divided by the 5 customers at the start, or 20%, right? And the new customers don't go into the churn rate because that's about your customer acquisition, not about your churn. So now, let's see how we calculate churn. Remember, for retention, we used an inner join. And now for the churn calculation, it's actually going to be an outer join. So if any of you were on the stream yesterday, I know Mostfit was, most of you probably, the rest of you probably were not. So I'll explain this. To do the churns, you actually do a left outer join. Now a left outer join is a join where you take all the rows from the first table, you try to match the second table by the join key. If there are matches, you put in the matching results, but if there are no matches, you put in null results. So the result of the left outer join will be all the customers at the start. And for those that churn, there's no end result, so you have a null in the ending account ID. Now that's fine because we want the churn customers. So we're going to do this where clause where the end account is null. Now that's actually like, the trick that is going to happen here. That's how we find the churn customers, by doing a left outer join and then select where the end account is null. If you're thinking about this, you could also do acquisitions with the right outer join, but I'm not going to go into that today. Let's just go look at the code for the churn rate SQL. Oops, not that code, this code. We can actually just modify this listing. And I'll just run listing 2 now, which is going to be the standard churn rate. And we'll see what is the standard churn rate for my new simulation. And how does net retention compare to it? Now, I hope it's different. All that hacking was to try to make a churn rate that's not exactly equal to the net retention rate. So I'm just going to let this rip. It should just run the new. Okay, so now, here we go. The churn rate is actually 6.8%, but let's take a look at the SQL. I'm going to do the same trick again. I'm going to copy this SQL out of the printout from the console, go into SQL editor here, and run it. Now let's look at the new SQL. It starts out the same. This is the standard churn rate SQL. It starts out the same as net retention, but we do the start accounts the same as net retention and the end accounts the same as net retention. We're just selecting the customers who are active at the start and the end. Again, by comparing the subscription start and end dates to the start and end dates for the churn calculation. Now here's the key, is the churned accounts. This is where my left outer join is. So it's start accounts, left outer join end accounts on the account ID where the end account ID is null. So let's just look at that output. So here we'll do select star from churned accounts. Let's look at them. So there's actually not much to see because look, it's just like it's just like the account ID. I could put in the end account ID here, and it might make it slightly more interesting. They're all null, right? That was the point, because I have the where clause where the end account ID is null. Okay, so going back to the full SQL, we get those churned accounts in this common table expression, and then we just count. The start count and the churn count are just the number of customers. So we're just doing count star. And then finally, the churn calculation is the number that churned divided by the number at the start. And the retention rate is, 1 minus that. So executing that again, whoops, I messed it up. Because I was selecting something. Let's see. All right, so now we've got the churn rate is 6.8% and the retention rate is 93%. If we go back, let's see, this is now the net, nope, not the net retention yet. I'm trying to go back to the net retention. Nope, still not. Maybe I should just copy it. Wow, this SQL, this history is not so useful. What happens if I click on this? Well, that's actually not so helpful either. So I'm trying to see the end of the query. Sorry people, trying to get back to the net retention query, and this thing is messing with me. Is this it? Nope. All right, finally, here's the net retention rate. So, the regular churn retention rate for the simulation was 93%. The net retention rate is actually only 91%. So in this case, actually, the net retention rate is lower than the churn rate. Now, what does that mean? That actually means there must be more downgrades. Because remember, I never really figured out the difference between the probability of upgrade and downgrade, because I was sort of rushing through it. I think I'm going to work out the details offline. Let's keep going to back to the explanation here. This thing keeps opening, and that's not what I want. Let's go back to the explanation. The churn rate, the standard churn rate, it does not reflect upsell or downsell, and it is good to use when you want to ignore price differences. Now, when do you want to ignore price differences? Generally when they're not that significant. Like if you have discounts and they're transient discounts, if people's discounts expires, the amount you charge them will go up, and that will look like an upsell if you're doing the net MRR calculation. And if you're doing that, then the expiration of your discounts would influence your churn result, which you wouldn't want. Now, if you have a few prices that are not too far apart, it's kind of similar. The problem comes if you have a wide range of prices. Now, if you remember what we did in our simulation today, the lowest price is $60 and the highest price is $500. If you remember, I set that in this little, data table that we loaded into the simulation. So our highest price is around 10x our lowest price. I should have just made this 50, so it would be like an even 10x. So now in this situation, the standard churn rate is not that good a choice because your high-price customers are worth a lot more than your low-price customers. Here in my simulation, I've only got high price equals 10x the low price. But in enterprise software, which is where I work in my day job, it's very common to have your highest paying customer pay 100 times your lowest paying customer. And in that case, it doesn't make sense to do the standard churn rate because you don't want to value all the customers equal. Now that's where revenue churn comes in. This is proper revenue churn, which is different from net retention. So the revenue churn is basically like you're going to take the net retention but not include the upsells. Now why does that make sense? Because the churn is supposed to be about your unhappy customers. It makes sense to include the downsells because those are unhappy customers switching to a lower plan, whereas your happy customers, stay on a higher plan. So including the downsells with churn is actually the best way to measure your losses due to customer unhappiness, which is what the revenue churn calculation is going to try to do. Here's a revenue churn toy problem example. Like in the previous examples, we have some customers on the start date on the left, some customers on the end date on the right. In the month in between, customer 2 churns, customer 4 downgrades, customer 5 upgrades. And what we get in the revenue churn is only the contribution from the downsell and the churn in the numerator. So that's downsell plus churn, 20 plus $29.99 in the numerator divided by the revenue at the start. So here you can see that in this toy problem, the MRR churn would be 56%, which is surprisingly high. Whoops, didn't want to go to the next slide yet. Surprisingly high, considering there was only 1 churn and 1 downgrade, but the upgrade, helped a little bit. Anyway, well, the upgrade doesn't help. That's actually the key. I'm misspeaking. These two actually cancel in your revenue, but not in your churn. So you still have 56% churn from unhappy customers. And the fact that you had an upgrade from 1 happy customer, that is not considered part of revenue churn. Also called MRR churn. I call it that generally. So the listing is actually MRR churn, listing 2.4. We're going to go try to run this, and pretty much that'll probably be the end of the stream for today. We'll have to get on to the other churn types next time. So edit configuration. Now I'm going to do listing 4. We're skipping 1. Listing 3 is activity-based churn, which I did yesterday, but we're not going to have time for today. So now let's just run the MRR churn listing, and I'll do the same thing where I take it out and show it to you. It looks like MRR churn is 9.4%. Let's see. And we can look at what the downsell, how much downsells there were. So I'm going to take this SQL out, put it back into the SQL editor, run it for you here. So now in this SQL, it's going to be very similar to the net retention SQL and the churn SQL combined, essentially. So like all these SQLs, it starts out the same. I set a start and end date, and then I select all the accounts active at the start date by comparing the subscription start date to the churn calculation start date. Apologize for using the same variable name there. I realize that's not the best practice. We do select the end accounts in the same way, but note that we're also selecting the total MRR for the start and end accounts. The churned accounts are just the same as in the standard churn SQL. We use a left outer join of the end accounts on the start accounts, but then select those where the end account ID is null, indicating that they actually churned because they had no matching record at the end date. And again, summing the total MRR. So now let's actually start to look at these pieces here. Let's look at the churned accounts. You can break up your, these long SQLs like this and just pick out some pieces. So here's my churned accounts, and we can see all of their MRR. Let's go back to the full SQL. And the next part is actually the key to making this revenue churn, is actually selecting the downsells separately in their own common table expression. So revenue churn has one additional common table expression or subquery in comparison to the regular churns. So now we select with an inner join, because downsold accounts are those, they have to be retained, right? So you select retained accounts with the inner join, but we only want those where the ending MRR is less than the starting MRR. And that's basically the definition of the downsell. Now let's actually see if there were any downsell accounts. I'm going to break up, see the SQL, select star from downsell accounts. Actually see if there are any. Whoops, oh, I needed the from. All right, so there are some downsell accounts, and we can see their downsell amount. I'm actually going to put in a few more lines of explanatory printouts here. We'll say this is going to be total MRR as start MRR, and I'll do e.total MRR as end MRR. I just want to take a look at these downselling accounts and confirm that they really are downsells. So here we go. So how many do we have? Only 10. Not a lot of sold accounts. And they appear to only be downselling from the premium plan to the standard plan. That might be actually a bug. I wonder if there's a bug in my code that prevents more of those. All right, but anyway, that's the current state of my simulation. I said I'm going to go back to fixing my simulation a little bit offline. I just actually wanted to get to the actual churn calculations within the stream today. All right, so then running the whole query again, in these final parts, I do these intermediate calculations for the churned MRR, the downsell MRR, and, well, I guess that's it. And then in the final query, we do the MRR churn rate and also show, how much was lost to each component. Whoops. You can't run these while you're selecting anything. So let's see. Our start MRR now was 94,000 for this made-up simulation example. The churned MRR was 5,900, so that's from complete customer losses. And the downsell MRR was 3,000. So actually, the downsell MRR contributes a lot. It's almost, it's like half as much as the churn MRR. So we end up with a 94% MRR churn rate due to the impact of the downsells. And now if we go back to the regular churn rate, let's go back to regular churn rate. Nope. More. Maybe I need to get it out of the SQL, because finding these things in the history has not been very helpful. It's been good to me. Let's see. When was I running the regular churn? Whoops. Let's see. Should be one of these. Sorry, just looking for the regular churn rate. This is the retention churn. Maybe this is the regular churn. Okay, so that was revenue churn is 9.4%. Regular churn is only 6.8% in this case. So that's actually a big difference. So that is actually showing for this simulation, the churn in revenue is greater than the regular churn, or for this business, if you believe this is a real business. So the downsells actually add to the losses, and you end up with, so this is around 6.8% churn just in terms of the customer count, but in terms of revenue, the monthly churn is 9.4%. That's a really big difference. So that just shows you that, that these downsells do matter, and it makes sense that your the revenue churn is going to be higher than the regular churn because we've included downsells in the simulation. Now it's not always exactly like that in the real thing. I think I've showed you the main things I wanted to get to today. I'll make a few more comments now This is the way it normally works. I was just talking about the comparison, and Gold's law of churn is violated by the simulation. I call this Gold's law of churn. This is the way it usually goes in real business-to-business products, in which case the customer churn is greater than revenue churn, and that's greater than net retention. The reason that customer churn is usually greater than revenue churn is that big spenders in real life churn less. Now that's not something we had in the simulation. If you watched me set up the simulation, there was nothing about the fact that people who spend more on the product are using the product more. That's usually the reason that revenue churn is less than customer churn, because your customers who don't use the product a lot are going to be on your basic plan and they're going to churn more. So in real life, actually, it's not like the simulation. In real life, revenue churn is usually less than customer churn, but that's because of the connection between paying a lot and being invested in the product. And then revenue churn is generally greater than the churn you calculate from net retention, and that's because of including downsells. So this is the way it really works in life. That's not what we saw in the simulation, but at least I changed the simulation enough so that you can see some differences. And I'll actually, if you're interested in this, I'll work on the simulation a little bit more, see if I can make it a little bit more realistic, and then I'll commit it. And then anyone who wants to try different revenue and regular churn can actually get a better simulation. So let's see, I've gone over an hour and a half. This is where I am on the plan. On yesterday's stream, I did activity churn. Today, we spent time doing the new simulation and then, of course, redoing those calculations. So I'm going to call it a day. It's been fun, but I got to get to the pet store before they close. Here's a summary from today's stream. I mentioned that fighting churn is about targeted interventions, things like improving your product, engaging more with your customers, and doing customer success and support. Churn compares the lost customers to the starting customers, and it could be the number of customers or the amount they pay. Acquisitions are always ignored for churn. Churn is easily calculated with SQL. When will I do the repos push? Well, shoot, man, I'll commit what I got right now. Well, let me finish I'm like getting ahead of myself. I'm easily distracted. Let me finish the summary and then I'll just push what I've got. And then we can keep working on it. Let's see. We talked today how there are multiple measures of churn. For consumer products, you want to use standard churn. For business products, you use revenue churn. And if you report to investors or outside people who are interested in your company, that's when you use net retention, because that kind of puts the best face on your churn. We didn't talk about ad-supported activity churn today. So now let's go out and I will just look at what hacking I did earlier in the stream. Here we can see all my changes that I did to make all these changes. Okay, I added a bunch of new simulation files, which are mostly just copies of the old ones. I changed the simulation, so I have a new plans file, and I had to put this little exception, and then I load the plans file, and then the customer can pick a plan, and customers now have MRR, which they save along with their subscriptions, and those have to get written to the database. I'm actually going to discard this hunk. I don't want to permanently set that to a 500 customer simulation, so I'm not going to keep that in there. In the customer, we added that they get an MRR and they can set it when they pick their plan. Then in the customer utility simulation, utility here is in the sense of like happiness or usefulness of the product. Now we have the new downgrade, simulate, upgrade, downgrade, which I really just hacked together. I'm going to have to do a better job on this, but we'll work on it. And let's see. Oh, this was just me kind of reformatting one of those sequels to show you. I want to discard that. And I guess that's really it. So there's also some part where I call that function. So where do I call the new? Okay, here's where I call simulate upgrade downgrade. So that's how I quickly hacked together upgrades and downgrades in the simulation. I'm going to commit that right now. Live stream hack to make upgrade downgrade. Now this would be less of a hack in my book if the amount the customer paid was actually related to their happiness. Then we might actually start getting some really realistic results where we could see that we should have it in the simulation that customers who pay more tend to do more, and also that if they pay more, they'll be unhappy unless they do more. But anyway, this was good enough just for a quick demo. All right, so anyone can find that in the GitHub repo. Hopefully if you come back with a better way to do it, that's all good by me. So before I go, just want to remind everyone my new schedule, 9 Saturday Pacific time and 3 Sunday Pacific time. Actually, next Saturday I think is going to be special, and I'm not going to do the 9 a.m. Pacific stream. I'm going to be doing, I think it's at 7 p.m. Eastern, 4 p.m. Pacific. I'm going to be streaming not on my channel, but on Manning Publications channel. Periodically, they have the authors stream on their channel. That was actually where I got my start streaming. Was the first time they asked me to stream on the Manning channel. I was like, okay. And it was so fun, I now have my own channel. So that's how I became a streamer. But this will be my second time stream. Next Saturday is supposed to be my next stream on the Manning channel. So I won't be doing my regular Saturday stream time. But I'll post that on Twitter or something. So, speaking of posting on Twitter, this is how you can keep in touch with me. I should mention that I have a blog website, fightchurnwithdata.com, shown here on the bottom right. If you want to connect with me on LinkedIn or follow me on Twitter, please do so. And you can get all my updates about the stream, about churn, Fighting Churn with Data, just other. I only post about professional topics related to either data science, churn, or the subscription economy, which is what we call the world of subscription companies. At my company Zora, we talk a lot about the subscription economy. So that's usually what I'm posting about on social. Don't worry, no pictures of my kids or my food and politics and stuff like that. Just data, churn, keep it professional. And of course, follow me here on Twitch, Carl24K Data Science. Hope you all enjoyed the stream today. And of course, there's a book that my current streams on data science are based on. I won't always stream about the book, but for now I'm streaming the book. So Fight Churn with Data, you can get it at Manning Books. There's a discount code here. So that's it. Thank you all for joining me today. Hope you enjoyed it. I hope it wasn't too hacky. And for those of you who are really interested, you probably learned a lot more about the simulation than you maybe learned when I was first doing it. Oh yeah, Rodrigo, we should connect on LinkedIn. Have to I think you need my email to connect on LinkedIn, but whisper me on Twitch and I'll send you my email and then we can properly LinkedIn connect. But anyway, I'm gonna go, like I keep saying, gotta get to the pet food store, do a little bit more errands before my Sunday winds down. So I hope you all really had a great weekend. Mine was good. Hope you enjoy the rest of your weekend, whatever you got left. Thanks for joining me, and I'm out.